Audible. Okay, fine, good. And you can see the presentation, right? Your screen, you're able to see the screen as well, right?
Yes, sir.
Okay. Now let us understand today the same example that we have seen yesterday. It was regarding the CRC protocol. So can anybody tell me immediately what was CRC protocol and how it was better than earlier two protocols? Who want to take lead immediately and tell me? Nobody. What is CRC?
Cyclic redundancy check.
That is the full form of CRC. I'm asking what is CRC? You haven't give up that the typical answer of yours. Whenever somebody asks you something, you will tell the full form, right? What is CRC? Cyclic redundancy check is the full form of CRC, but what it is? It is one of the error detection mechanism with which we can detect the error. But other than CRC, what different error mechanisms we have seen, error detection mechanisms we have seen? We have seen parity check and simple parity check, and then next was
Two-dimensional parity check coder, sir.
correct. So simple parity check and two-dimensional parity check. But what was the problem with earlier two methods? The first method, that is simple parity check, in which odd parity was used. So problem with that was, yes, Bhushan, either odd number of errors only will be able to detect it. Like if odd parity is there, then 1, 3, 5, 7, that those many errors is that the parity check could possibly detect. But even number of errors, if 2 bits got changed or 4 bits got changed, those could not be detected by that error detection mechanism. Then next parity check that we have seen was the two-dimensional parity check. So in that, what was the problem?
Only three errors can be detected, not more than three.
So if 1 bit got changed, 2 bits got changed, 3 bits got changed. So those many bits it can detect easily, but other than that, it could not detect it. So highest number of bits, highest number of bit error that could it detect was 3. So other than that, if 4, 5, 6 bits error happened, it could not detect it. So that was the problem with the two-dimensional error detection. Then if we go for CRC, here as many number of errors you want to put, you can put it. So those many, all those sorts of error will be detected here in CRC mechanism. So what was the difference between earlier mechanism or error correction techniques and this error correction technique is, earlier only one redundant bit they used to go for, where it will like the error detection mechanism was depending upon parity. Now, what has been done here in this method is, along with the their earlier method, it only used to go for parity. But here, what has been done is, in this method, they use a common divisor with which it divides the data word plus some random number of zeros been added. So number of zeros added here depending upon the total length of the divisor. So if divisor value is 4 bit, then 3 number of bits we used to add, and then that added with the data word, then we divide the generator and remainder here come at as in redundant bits, and then it will be transmitted. Then checker will do the exact reverse way which has been done at the generator, and if we get the output which is 000, which is sent, which is actually number of zeros added at the encoder sides, and if same syndrome we get at the decoder side, we say that there is no error occur in the data which has been transmitted, while if any value other than 0 appear at the decoder for syndrome, then we say that the error has occurred in any of the bits. Like it could be 1 bit error, 2 bit, 3 bit, 4 bit, 5 bit, whatever it is, and those many number of bits error will occur. So that is what the CRC encoder is supposed to work. And we have seen as many as number of errors we put here, all those errors will be easily detected. If it is even number of errors, it will be detected. Odd number of errors, it also will be detected. Like for two examples we have seen. One example is this, which is the example on the screen that we see, and then earlier example which we have solved on the, even you have solved two number of errors when occur as your homework, and you have solved it correctly also. You could be able to detect the error. Here the error was odd number of errors, that is one error occur. In your example what you solved was two number of errors, and both the errors got detected. So it has nothing to do with the parity, and that is why CRC is the most simplest form to go ahead with the detection of the error. Now is it clear to all the differences between CRC, simple parity check, and the two-dimensional parity check? And with the help of the sums that we have solved, similarly this table has been formed. Now here you can see the how it is indicated, like how CRC is nominated. CRC is always nominated in the fashion that C in brackets 7 comma 4. So what is this 7 here? 7 here is length of the code word, and 4 here is nothing but length of the data word. So from this C 7 comma 4, you can easily find out what is the length of the divisor. So here from this, how you can reach the length of the divisor? Code word is 4. Sorry, code word is 7. Data word is 4. That means how many zeros been added? 3 number of zeros been added, and if 3 number of zeros been added, obviously data this divisor will be 3 plus 1 is equal to 4. So 4-bit divisor is being used here in this CRC, in this type of CRC C7 comma 4. Is it clear to you? Yes, no, yes, no.
Yes, sir.
Yes. Okay. Thank you. Now we can go ahead with the next mechanism for flow control, but problem occurred here is some of you, like I think even Amit went wrong with while solving the problem. Along with that, few more people again went wrong to solve that particular problem, because they go ahead with the binary addition, binary subtraction, then the modulo 2 addition. With the help of binary bits, even only 7 number of bits were there for this dividend, and 4 number of bits for the divisor. You make some mistakes while finding out the answer. But remember, whenever we get involved into actual communication, data word won't be of 4-bit only. The data word length would be very, very high. And that is why if you solve this by this method of binary method, the more number of chances would be there that you make out an error. And that is the reason why we generally don't prefer to go ahead with the binary way to solving the CRC problems or CRC division. So what do we do here is we generally go ahead with with solving the problems with the polynomial form, and that would be our topic of discussion today. How a CRC problem can be solved with the help of polynomial equations. Now, can anybody tell me what is the polynomial form here? Let us say we have used a divisor here, like which we have used earlier. Now here, what divisor we have used? 1011. So if the binary value for divisor is 1011, then how do you represent it in the form of a polynomial? then we will see one more term, we call it as a polynomial degree, or in other words, degree of polynomial. So these two terms we will study now, and then we will solve the example with the help of polynomial form, which is very easy way to solve it. Now, can anybody tell me, if anybody knows what is polynomial? What is polynomial form? Okay, I'll tell you. Let us take simple example before going down there. Suppose I want to write a binary value of 1 into polynomial form. So how I will mention it? I will mention it as, I'll look how many bits are there. 2 bits are there, in which last bit always carry its unit value. Like say for example, आपण 11 हे डेसिमल मध्ये बघायचं असेल तर आपला शेवटचा जो 1 असतो त्याला आपण म्हणतो युनिट व्हॅल्यू. त्याच्यानंतर हा जो 1 असतो इथं बघा, थोडस याला साईज मोठी करतो. इज इट विजिबल फॉर यू नाउ? ओके. सो इथल्या 1 ची व्हॅल्यू, इफ इट इज डेसिमल फॉर्म, डेसिमल 11 नंबर असेल तर या डेसिमलची व्हॅल्यू काय असते? या 1 ची व्हॅल्यू असते युनिट व्हॅल्यू. म्हणजे आपण याला इथं कसं रिप्रेझेंट करतो? 1 into 10 plus 1 into 1. आणि मग त्याचं आपण we go ahead with the addition. So here it will become 10 plus 1, which is equal to 11. Getting it? आपण हे लक्षात येतं सगळ्यांना. So this way we try to figure out value of the unit positions of the data in decimal form. Is it clear to you all? Decimal form मध्ये 11 ला 11 ही व्हॅल्यू कशी येते? 1 म्हणजे 11 कसं होतं? तर शेवटचा जो 1 असतो त्याला असते युनिट व्हॅल्यू. म्हणजे तो जो व्हॅल्यू आहे ती व्हॅल्यू इथं आहे तशीच जाते. सेकंडचा जो युनिट येतो त्याला असते व्हॅल्यू 10 मल्टिप्लायची. सो त्याला मल्टिप्लाय बाय 10 होतं. सपोज आता हीच व्हॅल्यू झाली समजा 2011. सो 2011 ला आपण इथं कसं इंडिकेट करणार? वी विल राईट हिअर फर्स्ट 2 into, आता हे 2 ची पोझिशन कशी? हाऊ यू विल मेक आउट द पोझिशन? दिस इज युनिट. म्हणजे मराठीमध्येच म्हणायचं तर आपण याला काय म्हणतो? एकक. इथं दशम, याला काय म्हणतो? काय 100th पोझिशन. अँड दिस विल बी युअर 1000th पोझिशन. किंवा याला शतक आणि सहस्त्र असं मराठीमध्ये आपण याचे इंडिकेशन करतो. ही असेल आपली युनिट पोझिशन, ही असेल तुमची 10th ची पोझिशन, ही असेल तुमची 100th पोझिशन, आणि ही असेल तुमची 1000th पोझिशन. सो इथं 2 ची व्हॅल्यू फक्त 2 नसेल, ती असते 2 into 1000. नेक्स्ट विल बी प्लस 0 into 100 प्लस 1 into 10 प्लस 1 into 1. आणि मग ह्या सगळ्यांची क्युम्युलेटिव्ह ऍडिशन आपण करतो. दॅट विल बी 2000 प्लस 0 plus 10 plus 1, and then we reach out to the answer as 102011. That is 2011. So this way, when we go for finding out the details or data values in decimal, similarly, if we wish to go ahead finding out the polynomial form, then how do we mention it here? So if digital or this binary value of 1 if you want to denote, you will denote with last one here will be equal to only a single one. Then we have to add that 1 with the position of this 1 here. Now 1 here is value, it is denoted as x raised to 1, because it is the first position. This excuse me, sorry. So this one here is called as the unit value, and this one here called as the unit position. Here it is called as the first position. So इथं आपण याची इथं आपण याची व्हॅल्यू घेताना घेणार equal to x plus 1. लक्षात येतं? समजतंय का? स्क्रीनवरती दिसतंय, कळतंय?
हो सर.
Okay. Now, if I want to go ahead by mentioning the polynomial form of say 1, 1, 1. इथं जर polynomial form टाकायचं तर आपण काय करणार? We'll write it as x. इथं काय येणार? पोझिशन काय येईल याची?
स्क्वेअर.
स्क्वेअर. त्याच्यानंतर येईल
प्लस एक्स प्लस 1.
yes, x plus 1. Getting it? तसं 1 0 1 0 असेल तर काय येईल?
एक्स क्यूब प्लस एक्स.
x plus 1.
Very good. X cube plus
X plus 1.
एक्स
x cube plus
एक्स प्लस 1.
X plus 1.
That's it. Because unit position ची व्हॅल्यू इथं 0 आहे. ऍक्च्युली हे कसं डिनोट करू शकतो आपण? x cube plus x square into sorry okay into 1. कारण इथं ऑलरेडी तुमच्याकडे काय आहे? इथल्या पॅरामीटरची व्हॅल्यू काय आहे? 1. त्याच्यानंतर काय येईल? x square
Into 0.
into 0. हे दोघं वरती गेले, याला खाली आणूया. प्लस नेक्स्ट काय येईल?
एक्स इंटू 1.
इंटू 1. आणि त्याच्यानंतर प्लस काय येईल? 1 इंटू 0. आणि मग याचं आउटपुट फायनली येईल सॉरी x क्यूब प्लस x. कळतंय का?
Yes sir.
Okay. So 1 0 1 0 in polynomial form will become x cube plus x. Is it getting clearer to you?
Yes, sir.
Okay. So now whenever we now let us take an example here. Whatever the example that we have solved in polynomial form, how you will define this divisor? What would be the value of divisor in polynomial form? डिवायझर ची व्हॅल्यू आता पॉलिनॉमियल फॉर्म मध्ये तुम्ही काय लिहिणार?
X cube plus x plus 1.
करेक्ट. x क्यूब प्लस x प्लस 1. लक्षात येते हे सगळ्यांना कसं केलं ते? Now that will be your answer. That will be your polynomial value for the divisor that you have taken care of. Now let us go for what is the value of data word. आता इथे data word काय आहे? 1001. Data word is equal to 1001. Now what is the modified data word? Now how you will calculate the values? Now see this. You will try to look for, now don't go for counting the divisor value. Here don't go for number of bits of a divisor, because in examination they ask two kinds of questions. Question number 1, in which they will give you the binary value of the divisor, and in second form they will give you the polynomial form of the divisor only. They won't give you the value of the divisor in decimal form. They will give you directly in the polynomial form only. And most of the cases, like most of the exam paper, if you see, everywhere the polynomial form of divisor only been used. Now if the polynomial form of the divisor has degree of polynomial or polynomial degree, आता या टर्म वरती बघूयात हे नेमकं काय आहे. What do you understand by polynomial degree? It is the highest degree of the polynomial equation. म्हणजे आता या इक्वेशन मध्ये हायेस्ट डिग्री किती आहे? या 1 ची डिग्री काय? x raised to 0.
3.
या डिग्री काय? 1. इथं ऑब्वियसली काय आली? 3. So highest degree of equation इथं झाली 3. So what is the straightforward simple formula is your data word whatever it is, it will be checked with your divisor, and what is the highest degree of the divisor? In this case degree is 3. So how many zeros you will add? You will add 1, 2 and 3 zeros. What is the degree of polynomial? Those many zeros you will add here. लक्षात येते मी काय बोलतोय? जी पॉलिनॉमियल ची डिग्री आहे किंवा डिग्री ऑफ पॉलिनॉमियल आहे, हायेस्ट डिग्री जी आहे तेवढे झिरो तुम्ही इथं ऍड करायचे. म्हणजे तिकडे आपण जे -1 वगैरे करत बसलो होतो ना, तसं काही करत बसायचं नाही. इथं डिग्री ऑफ पॉलिनॉमियल बघायचे, तेवढे नंबर ऑफ झिरोज इथं आपण ऍड करायचे. हॅव यू गॉट दिस नाउ?
येस सर.
ओके. आता हे कोण बोललं? यस सर. दीपिका, यू जस्ट अनम्यूट युअरसेल्फ. आता इथं मॉडिफाईड डेटा वर्ड तुमच्याकडे रेडी झालं. कॅन यू टेल मी द पॉलिनॉमियल फॉर्म ऑफ द डेटा वर्ड नाउ?
x raised to 6.
आता हे कसं करायचं? यू जस्ट काउंट द नंबर ऑफ वन्स हिअर, नंबर ऑफ बिट्स हिअर. नाउ नंबर ऑफ बिट्स किती आहेत ते मोजायचं, -1 करायचं आणि हायेस्ट डिग्री वाटायला सुरुवात करायची. आता इथे किती आहेत? 1, 2, 3, 4, 5, 6, 7. सो याचं स्टार्ट कशी होईल? x raised to
6.
6. ओके. हा थोडा प्रॉब्लेम येणारच आपल्याकडे. ओके. x raised to 6 झालं.
6
पुढे काय होईल? प्लस पुढचे 0 आहे. 0
x cube
इंटू, नाही तुम्ही लगेच पटकन फास्ट जाऊ नका, सगळ्यांना कळेल असं सांगा.
into x raised to 5.
into x raised to
5 plus 0 into x raised to 4.
exactly 0 into x raised to
4 plus 1 into x raised to 3.
plus 1 into x raised to
3
3
plus 0 into x raised to 2.
2. Very good.
Plus 0 into x raised to 2.
x raised to 1 ना, आता म्हणजे फक्त x.
हा
2 झालं ना.
हा हा
आणि शेवटचं काय येईल?
plus 1.
0 into 1. आता याला मी थोडस, now can you see this?
Yes.
now the zeros, हा किती? 3 zeros आपण, राईट. सो आता तुमची पॉलिनॉमियल व्हॅल्यू काय आली? इथं 1 करायचं राहिलं आपल्याला.
Voice is not audible.
Not audible. Okay, just a minute. Is it audible now, Amit? Hello? And just
Yes, and now it is audible.
mute the video then. I'll close the video. Okay. Is it visible? Is it audible? Sorry. Audible आहे का सगळ्यांना?
Yes sir.
Okay. Now say this. आता कोणी कंप्लेंट? अमित ऐकू येते का आता?
Yes, audible.
Okay. So what we have done here is this stream of bit we have converted into this polynomial form. Now wherever 0 is there, just remove this and reach to the final conclusion. Now what the value will be?
X raised to 6
6
plus x raised to 4. X cube
x raised to
3.
So here the equation now become polynomial form of equation here. Now it become x raised to 6 plus x cube. आणि इथं आपल्याकडे काय आहे? Here you have the divisor value that is also mentioned in the polynomial form. You have here the data word, modified data word mentioned in the polynomial form. Now what will be the next situation, or what will be the next task? You have to divide this. You have to divide this by this. Getting it? This is your, okay, this is your the modified data word, and this is here your is the divisor, and you have to now go ahead with this division. कळतंय का कन्फ्यूज होतंय? हॅलो, लक्षात येतंय का? कन्फ्यूज होत असेल तर लगेच कळवा. Now, how do you find out this? How do you find out the solution? Now it's very easy as compared to binary. Once you done this conversion of binary value into polynomial form, rest is extremely easy. How you do it? Now tell me how do you whenever you go for multiplication of x raised to x raised to a and x raised to b, काय येतं तुम्ही आउटपुट काय घेता? डिग्रीज
x raised to a plus b.
a plus b करता. सेम तेच लॉजिक आपल्याला इथं वापरायचं आहे. नाव व्हॉट इज द डिग्री हिअर? हायेस्ट डिग्री x raised to 6. बरोबर, हे सगळ्यांना दिसतंय का? सगळ्यांच्या स्क्रीनवरती हेच प्रेझेंटेशन आहे ना? Everybody can see the screen, right?
Yes, sir.
Okay. So here you have the modified data word. Here you have the divisor value. Now you have to find out the remainder. How to find out? इथं डिग्री हायेस्ट बघा किती आहे? 6. आणि तुमच्याकडची डिग्री हायेस्ट किती आहे डिवायझरची? 3. म्हणजे इथं 6 पर्यंत पोहोचायला याला किती कमी पडतायत? x raised to 3 कमी पडतायत, राईट? So if we multiply this divisor by x raised to 3, you will reach out to the x raised to 6, right? So what we will do here is we will copy this and paste here. So what answer will be here now? Once you go for multiplication, this x raised to 3 will become now x raised to 6. Here it was x, so it will now become x raised to 3 and sorry, x raised to 4, no? And here 1 is there, so it will now become x raised to 3. हे कळलंय का सगळ्यांना काय केलं ते? बोला लवकर. हे बघा, आपण इथं काय केलेलं आहे? या x raised to 3 च्या टर्मनी इथं मल्टिप्लाय केलंय. सो मल्टिप्लाय केल्यानंतर काय होईल? x raised to 3 into x raised to 3. आन्सर विल बी x raised to 6. सेम वे x raised to 3 into x. इथं x आहे म्हणजे बेसिकली काय आहे ते x raised to 1. सो दॅट 1 plus 3 इथं होईल x raised to 4. आणि या x raised to 3 नी 1 ला मल्टिप्लाय केलं तर आउटपुट येणार आहे तुमचं x raised to 3. So while calculating the answer, how you will write up here? इथं उत्तर काय लिहिणार आता तुम्ही? ज्यांची व्हॅल्यू सेम आहे x raised to 6, x raised to 6, that will become 0. Now x raised to 3, x raised to 3, that will become 0. And what will be left only is x raised to 4. So this value now here become 0 plus x raised to 4. लक्षात येते का?
मायनस येणार ना?
कोण आहे ते म्हटलं? गेटिंग इट?
मायनस
काय केलं?
येणार ना?
काय झालं?
मायनस सबट्रॅक्शन केले ना?
बरोबरच आहे, बरोबर आहे.
हा, पॉलिनॉमियल फॉर्म मध्ये आपण एक्स रेस्ट समजा a रेस्ट टू 2 असेल मायनस a रेस्ट टू 1 असेल तर आपण तिथं डायरेक्ट मायनस पॉसिबल आहे का? नाही ना, कारण जोपर्यंत तुमचे पॉवर्स जुळत नाही तोपर्यंत तुम्ही डायरेक्टली ऍडिशन सबट्रॅक्शन करू शकत नाही. आपण इथं काय करायचंय, फक्त ह्या दोघांची पॉवर मॅच करायची. एक्स रेस टू 6 एक्स रेस टू 6 मॅच झालं की डायरेक्टली त्याची व्हॅल्यू येईल 0. एक्स रेस टू 3 एक्स रेस टू 3 मॅच झालं, तिथं पण व्हॅल्यू येईल 0. उरलं कोण मग? फक्त एक्स रेस टू 4 उरलं, तर एक्स रेस टू 4 तुम्हाला इथं रिमाइंडर म्हणून दिसेल. आता एक्स रेस टू 4 हे रिमाइंडर आहे, पण त्याची डिग्री याच्या डिग्रीपेक्षा लहान आहे का मोठी आहे? तर ऑब्विसली मोठी आहे. इथं तुमच्याकडे डिवायझर किती आहे? एक्स रेस टू 3 आहे, आणि तुम्हाला इथं अवेलेबल काय ज्याला डिवाइड करायचं आहे, दॅट इज एक्स रेस टू 4. सो व्हॉट यू विल डू नेक्स्ट इज प्लस. किती कमी पडतं इथं? एक्स कमी पडतं, एक्स रेस टू 1 कमी पडतं. सो आपण इथं काय करणार? वी विल गो अहेड विथ एक्स रेस टू 3 प्लस एक्स. इकडं या टर्म कडे लक्ष नाही दिलं तरी चालेल, बिकॉज दॅट इज नॉट व्हॉट यू आर इंटरेस्टेड इन. हे फक्त आपण काय समजायला म्हणून इकडे लिहितोय की इथली व्हॅल्यू खालची, ही व्हॅल्यू कशी आली, तर याला तुम्ही मल्टिप्लाय केलं म्हणून इथं आली व्हॅल्यू. सो इथं हे गोष्टी आपण लिहायच्या, पण दॅट इज नॉट युअर आन्सर. दॅट इज व्हॉट यू आर नॉट इंटरेस्टेड इन दीज व्हॅल्यूज. यू आर इंटरेस्टेड इन व्हॉट एव्हर कम्स ॲट दी रिमाइंडर साइड. लक्षात येते का? मग आता इथं काय लिहिलं आपण? एक्स म्हणजे एक्स रेस टू 1. सो यानं याला मल्टिप्लाय करा. सो काय होईल? आता आन्सर काय येईल?
x raised to 4
सो हिअर
Plus
व्हॅल्यू विल बिकम नाउ एक्स रेस टू 4. इथं काय येईल?
square
एक्झॅक्टली, व्हेरी गुड. आणि इथं काय येईल?
x.
ओनली एक्स. लक्षात आलं हे कसं आलं? हाऊ दिस टर्म केम फ्रॉम? वी यू मल्टिप्लाय दिस एक्स टू दिस टर्म, आणि मग व्हॅल्यू काय येईल तुमची? नाउ वन्स यू गो फॉर फाइंडिंग आउट द रिझल्ट ऑफ दिस, इथं जर तुम्ही वजाबाकी केली, आता काय होईल? एक्स रेस टू 4 एक्स रेस टू 4 पॉवर सेम आहे. सो व्हॉट विल बी द व्हॅल्यू हिअर? रिझल्ट विल बी इक्वल टू 0 प्लस उरलं काय? एक्स स्क्वेअर प्लस एक्स. सो ही टर्म आहे अशी इथं रिपीट करायची. लक्षात आलंय? नाउ this is what your reminder is. Now you check whether this reminder as compared to the divisor, whether the reminder's degree is less or more. इथली याची डिग्री काय आता? 2 आणि इथली डिग्री काय? 3. सो फर्दर डिव्हिजन इज नॉट ॲट ऑल पॉसिबल. म्हणजे बाकी उरली काय? फक्त एक्स स्क्वेअर प्लस एक्स. आता मला सांगा, वेन यू कन्वर्ट एक्स स्क्वेअर, just a minute, when you convert x square into x by the binary form, याला जर बायनरी फॉर्म मध्ये कन्वर्ट करायचं असेल तर तुम्ही कसं करणार?
1 1 0.
हा, जिथं जिथं इथं एक्स स्क्वेअर आहे तिथं आपण काय करणार? एक्स स्क्वेअरच्या ऐवजी 1 लिहिणार, कारण ती टर्म प्रेझेंट आहे, राईट. दुसरा एक्स पण प्रेझेंट आहे, तो पण लिहिणार. पण आता एक्सच्या नंतर काय यायला हवं होतं? या व्हॅल्यूला आपण कसं मेन्शन करू शकतो?
+1
एक्स प्लस एक्स प्लस
+0.
नाहीये म्हणजे काय? 0. आणि म्हणून इथं व्हॅल्यू काय? 1 1 0. सो अल्टिमेटली रिमाइंडर काय झालं आपलं? 1 1 0. समजले का? Is it clear to you?
Yes, sir.
Now check what is your reminder here which you have calculated. इथलं रिमाइंडर काय काढलं होतं तुम्ही? 1 1 0 काढलं होतं. and same answer you can get with the help of polynomial form. आणि इथं तुम्हाला खूप जास्ती स्टेप्स पण नाही घ्यायला लागणार. आय कॅन अंडरस्टँड, हे पहिलाच प्रॉब्लेम होता. पॉलिनॉमियल फर्स्ट टाइम तुम्ही बघताय असं वाटतं. दॅट बिकॉज ऑफ दॅट इथं थोडंसं तुम्हाला डिफिकल्ट जात असेल, बट इट इज व्हेरी व्हेरी इझी. इट्स एक्स्ट्रीमली इझी टू अंडरस्टँड. एम आय क्लिअर विथ दिस? हॅलो?
Yes, sir.
हॅलो सर.
Yes, sir.
कोण आहे? बोला.
स्वप्नील.
येस सर.
हा सर, पण ते -(x⁴) यायला पाहिजे ना, कारण सर आपण ब्रॅकेटच्या बाहेर मायनस असतंय, सगळं आतलं चिन्ह मायनस होत जाणार ना.
एक्झॅक्टली मला हेच सांगायचं आहे की दिस इज नॉट अ simple division. This we call it as a modulo 2 division, where we don't consider the signs. आपण इथं साइन अजिबात कन्सिडर करत नाही. लक्षात येतंय का? ही मॉड्युलो 2 डिव्हिजन आहे, ही सिंपल डिव्हिजन नाहीये. दिस इज नॉट अ सिंपल सबट्रॅक्शन ऑल्सो.
ओके.
इज इट क्लिअर?
ओके सर.
ओके. सो आता मी काय सांगेल तुम्हाला, सजेशन काय देईल, you just I'll keep the window open here. I'll just show you. Just go to YouTube. In YouTube, search for my name, right, Dhananjay Kumbhar. Then this is my channel, Dhananjay Kumbhar, and here you can see the number of videos. Now these are all okay. Go ahead with all the videos. Now here in these videos you can just scroll down, and here you can see the example for the CRC and CRC example and parity and CRC. Apart from these examples, I can show you this. On this platform it has been shown on YouTube, and as it has been solved for binary, I will put one more video today which will be only based on polynomial form, and I will solve 2 to 3 problems based on polynomial form, how to approach polynomial form, and then I'll give you the examples at the end of that problem, so that you'll get very much familiar with the polynomial form. Is it correct? Is it okay with you all? Hello?
Yes, sir. Yes, sir.
Okay, very good. So now I guess the time is over. I'll put the video by today itself so that you can watch it and just respond back to that video, right? And at the end of in that link itself, I will give you one example to solve. Rather, I will give you the snapshot of our question paper only. So there you can go ahead with the solving that example which was asked in the examination. You generally get a 10 marks question asked in the examination for that, so that you will understand, you'll realize that how easy it is, right? Is it okay?
Yes,
Okay, sir.
And parallelly, you just that kind of sessions where I will be recording myself teaching you the way I will be there in the class. So by that, just give me some feedback so that few other lectures also we can continue in that manner, right? Okay, now just check out with the attendance which is marked here. If somebody is absent, whose number is not here, just tell me. Just give me a minute. इथं काय हे लिहायचं का? कुठून इथं ते लिहायचं मूळ गाव का? डॉक्युमेंट्स आहेत त्यासाठी हां हां थँक्यू. ओके, डेट काय आजची?
10.
10 आहे.
हो.
का येत नाहीये? नक्की 10 आहे का 9 आहे आज? 10 Right, now it is available. Okay, so roll number 32, 13, 12. So this 12, 25, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It is not there. 14, 15, 16, 17, 18, 19, 21, 22, 24, 27, 20, 34, 35, 36, 37, 38, 39, 45, 47, 26, 28, and Kiran Patel. So Kiran Patel, your roll number is 57. Kiran, how many times I have to remind you, bro? You should write your roll number in front of your name. So write in a format A-57. And similarly, these students also. मनाली राजमाने मध्ये फक्त एक डॅश टाका प्लीज, कारण हे तुमचेच नंबर आहेत जे वेगळे जातात. सुशांत, तुझं नाव राहू दे मराठीमध्ये, बट द नंबर यू शुड पुट इट इन इंग्लिश, राईट? सो A-32 in English, and you can add your name in Marathi. No problem. Don't give any space. Shraddha, you also don't give any space. ऐश्वर्या मामाने अंडरस्कोरच्या ऐवजी फक्त हायफन करा. प्रतीक्षा वागस अंडरस्कोरच्या ऐवजी फक्त हायफन करा. So that your roll numbers will be in sequence. For you also it will be easy for recognizing. Similarly, Sonali Vagas and Vare Saroja, just add a dash in your A-26, A-28. Okay, so anybody whose number is not there, just mention it. Everybody's number is there present. Okay, then now you can quit the meeting. The session is over. Thank you.